my slides don't do the planets justice because they're more cool than my slides. But I'm going to hit the highlights of Saturn. Now, I don't know if you remember, but actually, when it comes to the moons, does Jupiter have any moons that orbits it?
Yeah.
Yes, it has a lot of moons. So we're going to be talking about Jupiter's moons and Saturn's moons and Uranus moons and Neptune's moons, actually 3 parts from now. So coming up. But this is what Saturn would look like, okay, over the course of several years from our perspective. Saturn's axis of rotation is tilted. I think this says something about 27 degrees. But it kind of depends on where the Earth is as to kind of how we see it's tilted. It's kind of like a skirt, you know, if this is if I'm Saturn and this is my rings, okay, if I'm like that, that's the coolest way to see it, okay? But if you guys are Earth, if the rings are like this, okay, that would be more like this. That's not so cool through a telescope if you're trying to get a rush. Now, we'll talk a little bit coming up, but can you see that major, it's a gap in the rings, okay? That actually is I think it's the Cassini division. I get my Cassini division and Encke gap mixed up. But that's just like a little hole in the rings. When we talk about the rings of Saturn, we're going to see that it's not like I said a skirt, right? Skirt we think of like a fabric material, but actually it's just little rocks, little icy rocks that make it, okay? So it's not a solid thing at all. Now there's a close-up of Saturn's rings. Does Jupiter have rings?
Yes.
Yes. It does. So this is actually, the only reason we see a planet is not glowing on its own. The only reason we see a planet is because sunlight hits it, and that sunlight goes in all directions, including the direction of Earth. So if the sun were to stop shining, we would not see the planets. We'd run right into them. Okay, of course, if the sun stopped shining, we have a lot more problems than just running into the planets. So this is looking at, as the sun was shining on it, and this is looking at the underside. So some of these captions are great at telling like which spacecraft took them, because we definitely have had our fair share of spacecraft visiting these gas giants. So this is an artist's rendition. It's not a photograph of kind of those tiny little rocks that make up the rings that we see as kind of a solid. And I can't remember which spacecraft it was, but one of the spacecraft actually maneuvered through the ring material to get to the planet Saturn. So it can be done. So Saturn's rings, they're beautiful. Jupiter has rings too, but they're not so big. The rings themselves, even though they're kind of wide, they're pretty thin. 2 kilometers, is that about a mile? A mile thick. But they're wider than that. The reason they're so shiny, or they are shiny, is because they're coated with ice. The color of the planet itself and the rings is kind of this salmon sort of color. And that actually, because something gives off that particular color of light, is suggestive that it's got some of the building blocks of life, kind of the nitrogen and carbon containing molecules. Saturn's rings, like we saw a minute ago, sometimes you'll see the Saturn's rings like this, kind of what we call edge on, and sometimes you'll see them tilted so you can see the whole ring. I'm going to kind of talk you through the kind of sections of Saturn's rings. They are, beginning closest to the planet, C, B, A, F. So we have C, B, A, F. And we see that F is like the thinnest. C, B, and A are kind of, they have some substance to them. 2 major gaps, and I told you I kind of get these mixed up. 2 major gaps or divisions. We have the Cassini division, and then we have the Encke gap. The Cassini division is the one that you see through a telescope. The Encke gap is a little more subtle. When we talk about the moons of Saturn, one of the moons of Saturn is Pan, P-A-N, like Peter Pan. I think that's kind of cool. Okay. What else? So there's a close-up. We have a couple of close-ups here. This one was taken by the Voyager 1. Voyager 1 and Voyager 2 are still ticking. Ticking, I don't know how you want to say it. I'm pretty sure that these spacecraft, as they were designed, instead of having solar panels, these are my solar panels. Instead of having solar panels, they have some sort of like radioactive source that powers them. They are leaving the solar system. Leaving the solar system. And still kind of sending back information. But on their way past the gas giants, they took some cool pictures. So this is Voyager 1. You see the Cassini division that you would see through a telescope. The Encke gap or Encke division here, it's pretty thin. Okay? So you can kind of see, remember it starts CBA. CBA. And then the F ring is out here. So you can hardly see the F ring here. And this is just this was taken by Voyager 2. Don't they sound like twins? Voyager 1, Voyager 2. Sent up in, I want to say the 1970s. I'm pretty darn impressed with that engineering. All right. So the F ring, check this out. I don't think you will see the F ring through a telescope, okay? But you will see the Cassini division and probably not the Encke gap. So the thing about the F ring, don't go to sleep on me. Wake up. You need to bring some coffee or something, dude.
Okay.
The thing about the F ring is it's so fine you won't see it through a telescope, not through our telescopes. This is probably taken by the Hubble Space Telescope. But it's escorted, or that material is kept in place by two moons, Pandora and Prometheus. Well, that's kind of fun. This is actually showing us this spokes. So spokes are kind of like if you have a bicycle and you have spokes that kind of connect the inner part of your bicycle to the outer part of your, inner part of your tire. Tire, exactly. It's tire spokes. So I don't know if you can kind of see these wispy, ghosty looking things are spokes. So this is a close-up of the F ring and kind of the Prometheus and Pandora, keeping that F ring in place. Almost sounds like you're swearing, F ring. Like, but anyway. This is a famous picture that was taken by the spacecraft Cassini. So that little dot there is the Earth. What? That is the Earth. Yep. If you were on Saturn looking back at our little planet.
And then that's Saturn, that's right next to it.
Yes, ma'am. Yep, there's Saturn and there's the Earth. I know.
Is that, like they didn't put that dot there?
No, it's a photograph.
That is actually Earth.
Yeah, it's actually Earth.
What the heck? That's whack. That is whack.
I've heard. What? How long will it take to get to Saturn, or?
No, how come when we look out into space we can't see Saturn?
Saturn's so big?
Like, how come we can't,
It's not humongous like that?
It just seems
because
crazy.
It's so far away. I know, it doesn't seem in proportion, does it? Yeah, but yeah.
So then, tell me, all the little planets are behind that Earth, behind Earth?
Well, now remember the planets kind of change their position relative to each other, but yeah, so they're orbiting the sun, so there'll be different positions, but it just happened that things lined up that the spacecraft could get that picture too, because because the Earth could have been behind Saturn when the spacecraft was there.
That's
So how many light years away is Saturn?
I'm thinking we go, instead of light years, we go light minutes. So the sun is 8 light minutes from the Earth. And I'm thinking for Mars, you're talking maybe 13 light minutes. So one of the things we're going to do in Friday's lab is we're going to do a couple activities, and one of them is to kind of get relative spacing of the planets. So when you leave Mars, there's a lot of gap between Mars and Jupiter. So I have to look it up. It might be an hour or so. Yes, an hour for light to get from Saturn to the Earth. But to get this picture, there's a whole story behind that because, I've heard.
Uranus is right there, so it's under Saturn, right? Or
What's that?
ain't that Saturn right there?
Yeah, that's Saturn right here, and there's the Earth. Yep.
So this thing is right under Saturn almost.
Oh yeah, the spacecraft is right under Saturn. Yep. Yep. And as far as that goes, you know that the sun must be somewhere. This part of Saturn is shadowed, and this you can start to see kind of this part of Saturn is lit up.
Yeah.
So
It's just kind of crazy to think that when we look through that telescope, You saw like
The cute little tiny Saturn, yeah, and without the telescope.
Looks like an emoji.
I agree. It's striking. It is totally striking. So, what do you think about Saturn? Does Saturn have bands?
Yeah.
Yeah, Saturn has bands like Jupiter has bands. We call those belts and bands and zones, or belts and zones. Now, I'm going to take you out to the internet because you can't really see the six-sided. See, 1, 2, 3, 4, 5, 6, six-sided figure on top of Saturn. So remember, Jupiter, like Saturn, like Jupiter, doesn't have a solid surface, so it's gases and clouds. Okay, so that they call it the hexagonal shape, and I don't think they've known about it all that long. But here we go. These pictures look better, I think. It's not a video or anything. It's just some still images. I Googled images. But like, for instance, you can, see it. That looks prettier to me. That's like looking down at the North Pole, or I don't know which pole it is, but you can kind of see. Isn't that cool? And that has to do with kind of the dynamics of the gases that make up the planet. I just think that's neat.
So aliens.
What's that?
That's aliens.
Aliens work? Probably physics. Okay, so that concludes that part. And even though I don't have a slide that says homework is due, but is homework really, really due? No. But if you turn in this homework by, Friday, then you can get 11 out of 10 points.
And then homework today is not due after due to like 4, or
I think 3.
there you go.
Yeah. Or I think no, at the end of the day, like midnight, because if you're posting on Canvas, yeah. Good question. All right, so let's go into, you guys told me after Saturn is Uranus. So let's take a look at Uranus and Neptune. To me, they kind of go together. Why do I think Uranus and Neptune go together?
Blue.
They're both blue, yep, and they're both blue for the same reason, the same chemical. Exactly. Oops, that isn't. Oh, I must have put that. Oh, okay. I got this. So here they are in all their glory. Now, let's see. Would this be right? We have had the spacecraft Cassini. The spacecraft Cassini that took that cool picture with the little blue dot. That, I want to say, was an orbiter that orbited Saturn. Right now we have an orbiter, Juno, orbiting Jupiter. This is to say that these blue guys have had no orbiters. They've had no orbiters, but they've had flybys. So these pictures that we see are kind of flybys. Can you picture what a flyby is versus an orbiter? Yeah. So kind of from left to right, we have Uranus is this guy right here, and Neptune, thank you. Neptune is this guy over here, kind of from left to right. And to scale is the Earth. So what you're going to be doing Friday is you're actually going to be kind of using different objects to kind of get a sense of scale, and also you're going to be doing a strip of paper to kind of get a sense of distance between the planets. But which one do you think is bigger, Jupiter or Uranus? Jupiter's a lot bigger than Uranus, yes.
Isn't Jupiter like bigger than any other planet?
Jupiter's biggest planet, yes. Yes, sir.
I just thought of this. Wouldn't it be crazy if we were like the moon for one of those planets?
Yes.
That would be crazy.
That would be very crazy, because I have a whole little slideshow on the moons of these gas giants, because the moons are almost more interesting than the planets. Yeah. So one of the things about Uranus is, can you see some kind of like this?
Yeah.
What I'm drawing is its axis of rotation. I'm trying to show it spinning. Okay, so its axis of rotation is actually tilted into the plane of the ecliptic. So if that's the sun, and we're going to see that picture here, but it kind of orbits the sun like that. It's kind of crazy. Another kind of right off the bat, let's see, which planet has the great red spot? Jupiter, yep. And actually, it's a different blemish. It's called the great dark spot, but I'll put the letter N here for Neptune. We're going to see that the great dark spot was on Neptune. was, I say, and because I believe a second flyby, I saw that the great dark spot was gone. So anytime you see a planet that looks like it's like bluish and kind of tilted like that, that's Uranus. That is Uranus. So do you remember what angle is this? Like if I go from here, like that.
90.
90, yep. So it's about 90 degrees tilted into the plane ecliptic. So you can kind of see the rings. Does Uranus have rings? Yep. Does Uranus have moons? Yes. So
Is it really like red and teal like that, or is that just because it was a flyby?
I think sometimes those are like just kind of colors to bring out the different belts and zones. Because I think in the visual images, I think it's blue. That's a good question. This is bullseye arrangement. Okay, so here we see Voyager mentioned again. Voyager. Where's Voyager now? Off, leaving the solar system. Yep. So here's Uranus. And we used to didn't think Uranus necessarily had rings, because you can barely see the planet. By the way, if we get a chance to see the planet Uranus through the telescope, it's going to look like a little blue circle. A little blue circle. It's adorable. But so what happened was the word is occult. You see the occultation down here. Occult, occultation. Occult means to block. So basically, we could see that it had rings because that ring material would block the light from that star. So it would look kind of like this. We would be looking at the star. This is what we call a light curve. We're going to be looking at more light curves. This is a light curve where it maxes out. That means we see the star. This dip right here means that actually that star is being blocked out or occulted by ring material. And then from our point of view, the star passes out of the ring material. Okay, no occultation. Our light goes up. Occulting because of the ring material. Okay, no ring material, no ring material, and this is the planet. So this is like a light curve of this star from our perspective. Okay, so we found it by occultation. These little streaks actually shouldn't necessarily be there. They're boo-boos. They're just kind of, they come with noise. But you can see kind of this cool ring structure that actually, this also came from one of the Voyager missions flying by. That's pretty cool, of Uranus's rings. What a rush to be the engineer and they get excited if you've ever seen like NASA and they're waiting for information from one of their spacecraft or their probes. They're like, yes! Because they've had some failures too. So this is Uranus orbiting the sun. So you can see what I told you, that its axis of rotation is lying in the plane of the ecliptic. It's tilted like 90 degrees. So check this out. 2028 hasn't happened yet, right? 2049, but this is 1986 where it was. You can see that, does it take a long time for Uranus to complete one orbit about the sun? Oh yeah. And so actually, can you see where here, right here, if you live in the North Pole, you're going to have crazy intense rays from the sun, right? Well, if you live in the North Pole here, what's going to happen?
It's cold.
Really cold.
So it's cold for like a couple years.
It's cold for half of their year, but for a long time, exactly, because they're saying 84 years would be the orbital period.
Why does it take so long for one planet to just go around the sun?
Well, two reasons. One is that the orbit is bigger, but because like if this is Earth, this circle is Earth, our orbit.
Yeah.
And then this circle or this ellipse is Uranus, so it's bigger. But the other is that Kepler said that not only is it bigger, but it's traveling more slowly because of the gravity thing. So it's slower.
Okay.
It's which law is that? Kepler's, I want to say third law. So yeah, you can see here the North Pole. It's got all the sunlight here. Okay. But here at the South Pole, it's got all the sunlight for half a year at a time. And then this is kind of at the equator. Crazy, crazy, crazy. So which planet is this? Neptune. And what is this?
The dark spot.
Great dark spot, yes. Da-da-da-da. So this is photographed by Voyager. Like I said, I'm pretty sure the great dark spot is no longer there because we had Voyager go through, take it, and how long has the great red spot been on Jupiter? Do you remember ballpark? Is it like 100 years, 1,000 years? Jupiter, great red spot. 300, about 300 years. Oops, sorry. I know you asked about color, and this says that it's not really this blue, but that the blue color is exaggerated by the computer to try to bring out that color. So this is also Neptune. Kind of see some clouds. This was, let's see, it's not saying what it was, spacecraft it was taken from, but this was the spacecraft after Voyager. So I was gonna circle, if you printed these off and you were following me in your printed out copy of your PowerPoint slides, you could circle the word methane. Because as it turns out, Uranus and Neptune are both blue because of methane. So Jupiter and Saturn don't have that in their atmosphere to make them blue. Okay, this is, look at Neptune. You can kind of see Neptune's thin rings. So how do you get rings, right? Well, it's thought that ring material quite possibly comes from a moon, because these gas giants have moons, okay, that actually got too close to the planet and they got kind of shaking up and they broke up and created this material that creates these rings around these gas giants. Here's one thing about the rings though. Over time, and I've read this, over time the ring material actually will go away. So over time it won't be there forever. It'll kind of like fall into the planet or kind of get kicked out. So that ring material, for instance, we see the rings of Saturn, that won't be there. Your great-great-great-great-great-grandchildren might not see rings around Saturn. I don't know.
So that means Jupiter rings is falling off?
Jupiter's rings are getting dimmer too, you know. But another thing about Jupiter is you guys know there's lots of moons around Jupiter. So hey, if that moon material would kind of bump, like two moons that are kind of close, if they would like hit each other, they could crumble up and make a new ring around Jupiter.
Oh, so
Wouldn't that be cool if Jupiter has both the great red spot and cool rings? So this is Neptune. Blue. All right. So I kind of want to finish today kind of giving you a precursor to what we're going to talk about on Monday. Wait, is this focus?
This is Wednesday.
I know.
Friday.
Yeah, Friday is kind of like a lab day-ish. So we've been talking about moons, and like I said, on Monday we'll talk more about moons, but check out this little video. Moons that people can actually live on.